right, 3.2, exponential and logistic modeling. So the one note that's for this section is for an exponential population model. If a population P is changing at a constant percentage, or a constant percentage rate R each year, then P of T is equal to P sub 0, or that means P initial, times 1 plus R raised to the T, where P sub 0 is the initial population, R is expressed as a decimal, and T is in years, or T is time in years.
Is that a 0 subscript?
Yes.
Okay.
Yeah, it's just really little.
That's okay, Josh.
No.
I forgot the A.
Peyton, you have no reason to talk. You spelled percentage wrong.
Yeah, I thought of an S.
Oh. Oh.
Present.
Right, that's
Percentage?
Yeah. Apparently I was trying to spell
Right there.
present.
right there.
Not present.
Your
Okay.
parents, whatever.
It's years.
Oh,
Years.
I still spelled it wrong the second time.
Haha.
It's percentage, not percentage.
You know if we play Grace?
All right, so you say tell whether the function is an exponential growth function or exponential decay function and find the constant percentage rate of growth or decay. So P of T is equal to 4.3 times 1.018 raised to the T. So our P sub 0 is 4.3. And we need to remember that this 1.018 is 1 plus R. Okay, because that's what the formula is. So we have 1 plus R is equal to 1.018. So that means that R is equal to 0.018. Which that number is greater than 0. So that means that It is an exponential growth function. With a growth rate. We just have to move it over and make this a percent of 1.8%. Okay, if it's less than 0, it's going to be decay. This one's greater than.
Why is the growth rate 1.8?
So you take the R value and you just have to make it a percent instead of a
Oh.
decimal.
Okay. As soon as I asked the question, I looked at it and was like, oh.
Yeah, it like makes sense after.
I'm gonna go back now.
All right, number 6. They call it G of T. Doesn't really matter, but G of T is equal to 43 times 0.05 raised to the T. So what's my P0?
43.
So my initial population is 43. To find my R, I have to do 1 plus R is equal to 0.05. So what is R?
What did I just do?
So just subtract 1 from both sides.
-1. Wait, that's wrong.
0.05 minus 1.
-0.95.
-0.95. This value is less than 0. So, therefore, it is an exponential decay function. Now, this is a little bit different. It's a decay rate of 95%. Okay, so if it's decay, we don't put the negative sign on it. We just say it's decay instead of growth rate. So it's a decay rate of 95%.
This is easy. Well, we are also only on the second problem, so.
All right, determine the exponential function that satisfies the given conditions. So number 8, it says that the initial value is equal to 52, and it is increasing at a rate of 2.3% per day. So is this going to be a growth or decay problem? It's growth. My P0 is what? P0 is 52. And then my rate, okay, remember, it's R plus 1. So the rate is 2.3%. We need to make that a decimal, so it's going to be 0.023 plus 1, or 1.023. So then, how would I write it? P of T equals what?
52 times 1.024.
And then, don't forget to raise it to the T. All right, number 10, an initial value of 5. It is decreasing at a rate of 0.59% per week.
Spell initial.
So growth or decay problem? It's decay. P0.
5.
And my rate, or my R value,
0.0059. Plus 1.
so it's decay. So this number, if it's a decreasing, it would have been what kind of a number?
Negative.
So negative 0.0059 plus 1. Which I don't think any of you have your calculator out, is going to be 0.9941. So then P of T equals what?
It's gonna be equals 5 times 0.9941 raised to the t.
Yep. So these ones are, oh, well, actually, hold on. I do want to do this other problem first. Yes, let's do this problem first. Okay, we're going to do a word problem. That's just an example. It's not one of the homework problems. And then jump back to this section of problems, but farther down in it, and then do a couple more examples. So, and these word problems are very nice. Hint, hint. Suppose a culture of 100 bacteria is put into a petri dish, and the culture doubles every hour. Predict when the number of bacteria will be 350,000. So our initial value is 100. So our initial is there. So at 0 hours, we have 100. At 1 hour, any guesses? 200. Okay, because it would be 100 is the initial times, it doubles every hour, so 2 raised to the first hour. So then at 2 hours, it would be what? Or we can set it up first and then you can figure out what it's equal to if you want. So you have 100 times 2 raised to the 2. 400. So if I wanted to generalize this at t hours, it would be what? Like, what would my formula be? P of t equals what?
P of t equals
100 times 2 raised to the t.
Yep.
Oh, that was easy.
Forgot. This is why I hate this section doesn't teach. Well, you're going to get a head start on the next section because it doesn't teach you how to solve these yet. So, this is how you would get the general formula, okay, for that. But it wants to know predict when the number of bacteria will be this. So it wants to know how many hours will have passed when you have this amount of bacteria. So that means that's our P of T value there. So we're going to do 350,000 is equal to 100 times 2 to the T. So we divide by 100. So that gives us 3,500 is equal to 2T. Oh, sorry, 2 raised to the T. Skip like a line or two and then flip it. So do the 2 raised to the T equals 3,500. I'm going to show you the trick to solve these, which will basically give you a jump start on the next section. And then you'll need your calculator. So we have an exponential. The opposite of an exponential is a logarithm. Okay, so we solve an exponential using a logarithm. So we come down, come across, and up. So it kind of makes an L. Okay, that tells you you're using a logarithm. So this is going to be log base 2 of 3,500 is equal to T. So on your calculator, you'll see a log button, but that's not the button that you need. It's not the right button. That's for a common log, which is a log base 10. It's a log base 2. Okay, and again, don't stress out if you don't remember how to do this on your calculator because you'll be doing a lot of them in the next section. All right, so you hit math on the left-hand side. I have to go find it because that's been a while. All right, arrow down until you see this log base. You hit enter. Notice it's going to give you a little box to fill in and another little box to fill in. So you put the 2 in the first little box, arrow over, put the 3,500. What does yours look like?
So I get to this one, and then it just goes back to 1.
Okay, hit the log button on your calculator. I'm going to see if yours will actually do it. So get out of that, like go back to your no more second quit.
Oops, I don't know why that.
And then just hit the log button and see. Okay, yours does not ask you for that.
What?
It's going to be interesting.
Oh, great.
You can use my calculator. I don't know.
So logs just aren't gonna work?
I don't know why you don't have it on there.
It's not like... No, that's math. I mean, that's numbers.
I've never seen one that didn't have that before.
Yeah, it just doesn't... What does yours look like?
So when I arrow down, I have that before.
Oh, yeah, I just have solver and it's a 0. Why is it?
I'll let you use mine. So after you do this, you would just hit enter. And then that's your T value. So T is 11.77. Some people would want you to convert that 0.77 hours into minutes, but I don't care that much about that.
So what is the L thing?
So that's telling you that you had an exponential, it's how to solve. So you could not get the T out of the exponent without undoing it by a logarithm. And it works the other way too. If you start with a logarithm, you can solve it by an exponential. this section really should be taught after the next one, but oh well. All right, we're gonna go. We might save the other word problems for after we do the next section, and then like go back at the end of it and like finish these word problems. I'm not sure. Or I may just go ahead and show them to you, and then once you do that section, you can actually do these problems. I always forget that the section's like backwards. All right, so back to the problems. The same thing. Determine the exponential function that satisfies the given conditions. Number 16. Okay, or it can just freak out on me. The initial population is 250, doubling every 7.5 hours. So we have P of T is equal to, my initial is 250 times. So now just like how we had this other one and we said it was doubling every hour, so we had 2 was the, like where the R plus 1 is. So times 2 raised to the, now it's doubling every 7.5 hours. Okay, so we're actually going to have 7.5 times T for these ones. All right, and then the last one of those, number 18, the initial mass is equal to 17 grams, and it's halving, okay, so it's cutting it in half, once every 32 hours. So this one's going to be like the opposite of doubling, okay? So instead of a 2, it's going to be 1/2 this time. So we have P of T is equal to 17 is the initial times 1/2, and then I would put a parentheses around it because it's a fraction. But now it's once every 32 hours, so because it's halving it, it's actually going to be T divided by 32. So if it's halving it, it's made a fraction in the exponent as well. And if it's doubling, it's like that. All right. Another example that's not in the homework itself. Suppose the half-life of a certain radioactive substance is 20 days, and there are 5 grams present initially. Find the time when there will be 1 gram of the substance remaining. All right, so my initial is 5 grams. It's a half-life problem, meaning it's a decay problem. So that means that it's going to be 1/2 again for this one. So P of T equals 5 times 1/2. Any ideas what it's getting raised to?
T divided by 20.
Yep. To the T over 20. And sometimes your book will actually write it, just more of a FYI, if you're checking your answer, as 5 times 2 raised to the negative T over 20, which is the same thing. It just requires you to move the whole thing to the bottom. So I like writing it the other way, but that's how your book will write answers. So if we wanted to know when there was 1 gram of substance remaining, we would plug in the 1 equal to 5 times 1/2 raised to the T over 20. When I write it, I'm going to go ahead and flip it so that the exponential part is on the left. But dividing by 5, so I'm going to have 1/5 is equal to 1/2 raised to the T over 20.
Did you hear that? Ew.
So it's exponential. I undo it by a logarithm. So you have log base 1/2 of 1/5 is equal to T over 20. So it'll be log base 1/2 of 1/5 is equal to T over 20. So whenever you get this answer in your calculator, you'll have to then multiply it by 20. So if you wanted to do it in your calculator, you can type it this way as 20, and then you'd have to hit the math and get your log base 1/2 of 1/5 equals T. Peyton, do you want to? Oh, you can try it.
You said multiply by 20?
Yeah, so it'll be, so like you could actually hit 20 and then you could hit math and then do the log base, and it'll actually just do it all as one step for you.
Is the
Yeah, or if you've already typed in your log base, you can hit enter and then just multiply by 20 at the end.
Is the time in days?
Yes. What do we get?
G equals 46.444 days.
Sweet. Alright, and then I am going to do one out of the book, and then the one that you'll have will basically mirror this one. Same type of problem, just different numbers in it, really is all that changes about it. So I'm doing 34, you'll have 33. So the half-life, and I can guarantee at least one of these word problems will be on your quiz or test. The half-life of a certain radioactive substance is 65 days. There are 3.5 grams present initially. So then this is a two-part question. So part A says to express the amount of substance remaining as a function of time t. So I'm gonna have y'all see if you can tell me what I'm supposed to do here. So this is the first part of setting up the function. So any idea how I would set it up?
3 of t equals 3.5 times 1/2 raised to t divided by 63. Right? No.
65, but yes.
Oh, why did I write 63? Okay, my bad. I meant 65. Oh, it looks like a 63. That's right. 65.
So that's set up. So then part B says, when will there be less than 1 gram remaining? And if you want to eliminate you having to like swap sides with stuff, you can actually write this and then set it equal to whatever. It'll actually make it nicer. So 3.5 times 1/2 raised to the t over 65 is equal to 1. And then I want y'all to see if you can solve that one. And then tell me what you get.
Wait. Do we do 1? Because it says less than 1.
Yeah, we still use 1. Because you're going to end up getting a decimal, and you're not going to actually write all of the decimals, so it's going to end up. Nice.
You got 1. What'd you get? 117. I don't want 13. Oh my gosh, I did it again. I wrote 63. Why? What is my obsession with 63?
I don't know.
I don't know, that's a weird
And then I probably got what you guys got.
Do y'all have an answer?
Yes, 117.48. What in the world?
Everybody agree?
Yes. See, 117.48 days.
Oh, I thought it was
Wow.
Yeah, guys. Or else it's just really long.
Alright, there's your problems. Since there's not a ton of time left, I will officially not make them due till Monday. So you don't have to do them tonight, but you do have like 15 minutes, so you probably could knock out most of them.